So today we're going to talk about z-score and finding the probability for x values. Objectives, finding z-score and finding probabilities.
It is actually a button.
Well, so suppose you have a collection of data. You're the statistician and you collected the data. This is your sample. And in this sample, you have x values. These x values can be, for example, the SAT score of your classmates. It can be the effectiveness of a new vaccine for COVID-19 or any collection of data. We have x values representing the data in that collection. So a statistician use x values, convert them into z-scores, then they use z-scores to find the probabilities. So we take each x value, use z-score formula. This formula is given as z equals to x value minus the mean of the collection divided by standard deviation. Then we can use either x or z to find probability. So when we use a z-score, when we have a normal distribution, we're interested in converting x values into z-scores. So once again, z is equal to x minus the mean. So we need to have the mean of the collection divided by standard deviation. We need to find the standard deviation. Then we plug all of them into the formula and we get our z-score. For a normal distribution, remember that some important experiments and the data that we're collecting, like IQ scores, shoe sizes, weight, height, these all follow a normal distribution. So for a normal distribution, the graph is a bell-shaped graph. The graph is like this. So on horizontal axis, you have your x values. After we have our x values, we convert them into z. But the graph is like this. A bell-shaped graph. So note that, first of all, the tails and the graph are not touching each other. There is a distance, there's a small distance between the green graph, the bell-shaped graph, the normal distribution, and x values. In the middle, we have our mean. So the mean or the balancing point is in the middle. This is our mean. One standard deviation above the mean, two standard deviations above the mean, And 3 standard deviations above the mean are actually dividing the right-hand side. So here you have this scaling, mean plus 1 standard deviation. Then we have mean plus 2 standard deviations. And finally, you have mean plus 3 standard deviations. We get the same scaling on the left-hand side, but instead of adding, we do subtraction. Mean minus 1 standard deviation, mean minus 2 standard deviations, and finally, we have mean minus 3 standard deviation. Before using a calculator, we can use empirical rule to find the percentages of the data near the mean. So empirical rule says empirical rule if we have a normal distribution, if we have a bell-shaped graph, 68% of your data is in between 1 standard deviation away from the mean. 68% of data are distributed in 1 standard deviation away from them. So how do we visualize that? 1 standard deviation away from the mean, and you know the data are below the graph of the curve in between the green graph and the horizontal axis. 68% of the data are located or are distributed in 1 standard deviation away from them. 1 standard deviation and 68% of the collection. 68% of all students in the class have, for example, average exam near the mean. 68%. It says 95% of the data in your collection for a normal distribution are distributed in between 2 standard deviations away from the mean. And so 95% of data are distributed in 2 standard deviation away from the mean. Okay, 2 standard deviations. Let me find a different color. 2 standard deviations away from the mean. Let's count for the whole area, so it includes everything. 95%. 2 standard deviations. And finally, it says 99.7% of the data are distributed in 3 standard deviations away from them. Okay, 99.7%. 99.7% is going to be roughly here. So we're going to use a different color. 99.7%. Almost include everything in our collection. So this is called empirical rule. Later on, we're going to use a calculator to help us find these percentages or probabilities. Z-scores and normal distributions. Introduction. There are many populations in the world. For example, there are people of different nationalities who live in different places and do different kinds of work and who have different kinds of job experience. Sometimes we need to compare values from different populations. People often say, you can't compare apples to oranges, but in statistics, we do it all the time. Well, how? The secret is in the standard deviation. The standard deviation allows us to compare values between different populations. In a previous lesson, we learned that the standard deviation is an average distance from data values to the mean. We use the standard deviation to measure how far values are from their mean. Let's try these. A company has a job opening for a high-paying and important position. It's only hiring one person for the position. Your team will recommend the candidate who will get the job. After much work, your team narrowed the choice down to two outstanding candidates. Both job candidates are well regarded and equally qualified. The last step of the hiring process is a personality test. The job is going to be very stressful, and the company believes that the personality test will reveal whether a candidate can handle stress or not. Both candidates have the results of such a personality test in their file. Unfortunately, they didn't take the same test. Using the following results, whom do you recommend for the position? Be prepared to justify your choice to the company chief executive officer. Candidate A, name of test taken, stress sanity simulator, mean score. Well, these are important information. Mean, standard deviation, and the X value are given. So the mean score is 740, standard deviation is 30, and candidate score is 800. For second candidate, candidate B, name of the test taken is mind management. The mean for this test is 65. The standard deviation for this test is 10, and the candidate score or the X value is 95. How do we compare these two candidates? So let us go to the board, write them down. So in this example, we have two candidates. Candidate A and candidate B. What is our goal? Our goal is to try to compare these two candidates. But what information are given to us? The first information is you have a test, and for this test, the mean is 470. I'm sorry, 740, 740, and the standard deviation for this test is 30, and the X value for candidate A is 800. Well, since we have X value and we want to compare the first candidate to the second candidate, we're going to find z-score. The z-score follows this formula, x minus the mean divided by standard deviation. So z-score is x, which is 800, minus the mean 740, divided by 30. So let us just put an index here, z sub a. It means that you're working with candidate A. We need to calculate this number. For the second candidate, the information that we have, that candidate took a different test. For this test, the information that we have, mean is 65. Standard deviation is 10, and x, the score of the second candidate, is 95. Well, we need to find the z value. Z is x minus mean divided by standard deviation. So our z is equal to x, which is 95, minus the mean, which is 65, divided by standard deviation, which is 10. We need to calculate these two z-scores, z-values, to be able to make the final decision whom to recommend. So here we have 60 divided by 30, which is 2. The z-score for the first candidate is 2. And here we have 30 divided by 10, which is 3. We say that since the z-score for the second candidate is higher than the z-score for the first candidate, we recommend the second candidate. Since the z-score for candidate B is higher than the z-score for candidate A, we recommend candidate B. Let's get back to the note. Next step, standard deviations are used to measure how far values are from their mean. A sample standard deviation is denoted by S, and a population standard deviation is denoted by sigma. So Greek letter sigma. Question 2 says, a grocery store owner rates the quality of her oranges on a 0 to 20 scale. She has 15 oranges with ratings listed below. For this problem, we will think of the 15 oranges as an entire population. We have 12, 10, 10, 8, 10, and the rest of the ratings. We calculate the mean of this population, and we say that mu is equal to 10. We calculate the standard deviation of this population, and we say that, hey, sigma is equal to 4. Part A of the question says, what does the standard deviation tell us about the variability with respect to the population mean? And B, suppose you buy the orange with a rating of 14. Is this above or below average in quality? How far does this value deviate from the mean? Well, we have a population. is population. We have mean, which is denoted by mu. Remember that when you're working with population parameters, they take on grid symbols. So in this case, we have mu, which is 10, and sigma, which is 4. Standard deviation for sigma is equal to 4. And we want to know, what does the standard deviation tell us about the variability with respect to the mean? So to answer A, we can say that the average distance or the average rating, the difference between ratings of oranges from the mean, which is 10, is 4. To answer part B, it says, suppose you take an orange and the rating is 14. What's the meaning of that? The rating of the orange is 14. It means that we have our X value. We need to calculate the Z-score. Z is equal to X minus mean. This is the formula for our Z-score. We have our X, which is 14. We have our mean, which is 10. And we have our standard deviation, which is 4. Just plug them in. 14 minus 10 divided by 4, which gives us 4 divided by 4, or 1. So the Z-score says this orange with rating 14 is located in 1 standard deviation above the mean. This orange is above average. The average is 10, and it's 1 standard deviation above the mean. We say that this orange is above the average. And part C says, how far does this value deviate from the mean? It deviates by 4 points. By 4 points in rating. Let us move on to next page. How many standard deviations is this? The number of standard deviation that a value is from the mean. X is 14, we calculated that Z, it was equal to 1. Now it says, what if your X is equal to 18? It means that we pick an orange and the rating is 18. What does it tell us? Part G says, we have stated before that the deviation of a value like X from the mean is denoted by X minus the mu. The Z-score of X is the number of standard deviations from X to the mean. Use this information to find the formula for Z-score. And eventually it says, use your formula to determine the Z-score for an orange with a rating of 4. And what does it mean when a Z-score is negative, and interpret that result. So we have calculated the Z-score for X equals to 14. Now it says, What if we have an orange with rating equals to 18? What is its z-score? Z is equal to x minus the mean divided by standard deviation. So z is equal to, your x is equal to 18, 18 minus the mean is 10, divided by standard deviation, which is 4. We get 2. As you can see, the z-score for orange rating 14 is less than the z-score for orange with rating 18. So it means that they have a better quality in this orange. Part H says, what if your X has a rating 4? So the z-score for 4 is 4 minus the mean. Our mean is equal to 10 divided by standard deviation, which is 4. So we have negative 6 divided by 4, negative 1.5. Our z-score is a negative number. What's the meaning of that? It means that it's below the average. Is below the average. Well, let us move on to find some probabilities related to a normal distribution. Normal distributions. In previous lessons, we discussed continuous random variables and their probability distributions. The values of a continuous random variable cannot be listed in order. This happens because for any given value, there is no next value. There is no next height after 6 feet tall. We have seen that some distributions of probabilities for continuous variables are shaped like a bell, symmetric, with a high, middle, and low ends. Many bell-shaped probability distributions are called normal. When we say that the bell-shaped probability distributions are normal, we don't mean in most cases that they are perfectly normal, but many of these distributions are approximately normal. Soon, we will give you some rules to help you determine whether a population is approximately normal or not. So, in this example, we have a bell-shaped graph, adult male height, which follows a normal distribution. The mean is given to us as 69 with standard deviation equals to 1. Remember that the total area below the curve is equal to 1 or 100%. So when we say 1 is 100%. The normal distribution. Normal distributions always have the following characteristics. The mean and median are equal to each other, and it's always in the middle of the horizontal line. The normal curve is bell-shaped and symmetric with respect to the mean, and the area below the normal curve is equal to 1. Normal curves extend endlessly in both directions, but are very nearly zero for values more than around 4 standard deviations above or below the mean. The normal curve changes its curvature from upward to downward. So upward curvature, downward curvature, and upward curvature. We call these 2 points inflection points. Again, remember that the mean is in the middle, 1 standard deviation above the mean, 1 standard deviation below the mean, 2 standard deviations above the mean, 2 standard deviations below the mean, and finally 3 standard deviations above the mean, 3 standard deviations below the mean. A normal distribution is determined by its mean and standard deviation. For example, one normal distribution might have a mean of 23 with standard deviation equals to 1. This is our curve C. Mean is 23. Standard deviation is 1. Or another normal distribution could have a mean of 15 with standard deviation equals to 1.5. So we identify the mean, which is 15. 15 is here. So it means that it corresponds to curve A. With standard deviation, 1.5. Okay, let me go over one example for probabilities for you. So this is our empirical rule. We discussed the empirical rule at the beginning of the class. So in example 10, suppose X represents a random man's height. We want to know the probability that the man is between 72 and 78 inches tall. We want to use the probability to calculate this. Note that we can find the probability X greater than a number, X less than a number, and X in between 2 numbers. So this is example 10. The mean is given to us. So let us get back to our note, find the given mean. The mean is 69 inches, and the standard deviation given to us is equal to 3. We want to find the probability that X is in between 72 and 78. We want to find the probability that X is in between 72 to 78. What is the probability? Well, turn on your calculator. Go to second vars. We need to find normal CDF. Normal CDF. Our lower limit is 72. So we're going to write 72. Our upper limit is 78. The mean of the collection is 69 with standard deviation equals to 3. So the probability is almost 16% or 15.73%. So the probability that we randomly select one person and that person has height in between 72 and 78 is 15.73%. So to use your calculator, you go to second, VARS, and you find normal CDF. Based on the question, if the lower limit and upper limit are given to you, you just enter lower limit 72, upper limit 78, the mean is 69, and standard deviation equals to 3. Let us take a look at question 11. X is greater than equals to 75, X is less than 72. We want to find each of these probabilities. X is in between 63 and 78, 60 and 66. So now we want to find the probability, question 11, that X is greater than 75. You randomly selected a person and you want to know what is the probability that the height is greater than or equal to 75 inches. So second, VARS, normal CDF. So in this case, your lower limit is given. Our lower limit is 75. I expect you to ask, what is the upper limit then? When the lower limit is given to you, the upper limit says all X values that are greater than or equals to 75. What you're going to select, you're going to select 1,000 or 100, 10,000, a very large positive number as your upper limit. So your lower limit is 75, your upper limit is 1,000, the mean is stay as 69, standard deviation stay at 3, and we calculate the probability. This probability is 22.75%. Part B says, find the probability that X is less than or equal to 72. So now we want to find the probability that X is less than or equal to 72 inches. In this case, it says X is less than or equal to the upper limit. So upper limit is given to us. What's the lower limit? The lower limit is going to be a very small number. In this case, your lower limit is going to be a negative small value, like negative 1,000. So, second, VARS, normal CDF, your lower limit is negative, so the negative sign is not subtraction. The negative sign is this negative in parentheses, minus 1,000. Your upper limit is 72. Mean is 69. Standard deviation is 3. And paste. It's going to be 84.13%. This is the probability. Let us take a look at part C. It says, find the probability that X is in between 63 and 78. So part C, find the probability that you randomly select a person and that person height is in between 63 to 78 inches. Our lower limit is given 63 and our upper limit is also given as 78. The mean is 69, standard deviation is 3. So let us go to second, VARS, normal CDF. Our lower limit, 63. Our upper limit is 78. Mean is 69, standard deviation is 3, and paste. It's 97.59%. And finally, part D says find the probability that X is in between 60 to 66. We go to second VARS, normal CDF. Our lower limit is 60. Our upper limit is 66. Mu is 69. Standard deviation is 3. And here we go. We get 15.73%. This is our probability that we randomly select a person and that person height is in between 60 to 66. So note that the mean is 69 with 3 standard deviations below the mean.